All right, let's get into something really cool today. We're going to take a concept from a story that so many of us love and spin it into a serious, honest-to-goodness scientific thought experiment. And it all boils down to one massive question. What if our entire universe runs on a single, inescapable rule of balance?
Yeah, you know this line. I'm almost certain you do. It's the first law of alchemy from Full Metal Alchemist. It's a principle of conservation that just feels right, doesn't it? It's the bedrock of an incredible story about sacrifice, cost, and consequence.
But this is where we take the big leap. What if we stop treating that as a line from a story and start treating it as a scientific postulate, a law that's even more fundamental than gravity or the conservation of energy, a rule that governs literally every single interaction in the cosmos, from a tiny particle decaying to two galaxies colliding?
So let's do it. Let's actually try to build this law from the ground up and just see where it takes us. We're moving from a really compelling story to what could be a rigorous scientific hypothesis.
Okay, we've got to give it a name. Let's call it the Law of Equivalent Exchange, or LEE for short. The big idea here is that the universe operates like a perfectly balanced zero-sum ledger. Nothing is ever truly gained or lost. It's just reconfigured. Every single gain has to be paid for with an equal and opposite cost.
Now, for any good law to work, you need rules, right? And for our Law of Equivalent Exchange, we're going to propose 3 foundational axioms. Think of these as the pillars that hold up this whole cosmic accounting system. Let's break them down.
First up, the law itself. The total equivalent value, we'll call it EV, of any closed system has to remain constant. Always. And what's so wild about this is that value isn't just mass or energy in the way we usually think about them. Nope. It's a new fundamental quantity that accounts for everything that makes something, well, what it is. And that brings us to our first rule, intrinsic valuability. In this framework, everything, and I mean everything, has a measurable worth. A single electron, a star billions of light years away, even an idea, a piece of information. It all has a specific, positive, quantifiable value on the universe's grand ledger.
So this is where the trades happen. Axiom 2, transformational balance. It's simple. For any process at all, a chemical reaction, a star going supernova, you brewing your morning coffee, the total value of all the inputs must exactly equal the total value of all the outputs. No profit, no loss, just reallocation.
So what keeps the whole system honest? What enforces the rules? That's Axiom 3. We propose a universal equivalence field, kind of like the Higgs field, that permeates all of reality. And its only job is to be the cosmic accountant, to enforce the balance. If an imbalance even tries to happen, this field instantly steps in and forces a correction. The books are always balanced, period.
Okay, so how in the world would we calculate this equivalent value? Well, here's a simplified way to think about it. You'd start with the raw energy of a thing. Then, you'd add value for the information it contains, how it's organized. After that, you'd add a premium for its complexity. But, and this is the kicker, you always have to subtract a mandatory entropy tax. It's the universe's fee for doing business, its unavoidable slide into disorder. It's the fundamental reason why no process can ever be 100% efficient.
Let's make this concrete. Say you want to turn a chunk of boring old graphite into a beautiful diamond. They're both just carbon, right? But one is obviously way more valuable in our system because of its complex, ordered crystal structure. So how does the law of equivalent exchange handle that?
Okay, let's look at the ledger for this transaction. On the input side, you've got the value of the graphite plus the insane amount of energy you have to pump into the system. And on the output side, you get the much higher value of the diamond. But wait, the ledger isn't balanced. There's value missing. So where did it go? It was paid as that entropy tax. All that waste heat and disorder created in the process? That's not just a useless byproduct. In our system, it is the payment. It's the value that balances the cosmic books. And this perfectly explains why real-world alchemy, or anything like it, is so incredibly difficult and inefficient.
All right, so the ledger balances for diamonds. That's neat. But for LE to be a true law of the universe, it can't just work on Earth. It has to hold up everywhere, especially in the most bizarre, extreme places we can possibly imagine. So let's take this idea to the edge of reality.
Now, for this law to actually play nice with Einstein's relativity, our equivalent value can't be a squishy concept. It can't change just because you're moving really fast. It has to be a cosmic constant, an absolute. The balance has to hold true whether you're standing perfectly still or whipping past a black hole at nearly the speed of light.
And look at how the stakes of the transaction change. Here on Earth, an exchange costs you some energy and some material. But near a black hole, the cost of that same exchange now includes the currency of space-time itself. Things like gravity and time dilation become actual line items on the cosmic ledger. The cost gets way, way higher.
And this is where Lie starts to get really powerful. It gives us a completely new lens to look at some of the biggest puzzles in physics. That spooky action at a distance of quantum entanglement? Maybe it's not so spooky. Maybe it's just two particles sharing a joint value account. Black holes, they become the universe's ultimate accountants, and Hawking radiation is just them slowly paying back the value they've taken in. And the Big Bang? Wow, perhaps it was the ultimate trade, the universe exchanging the infinite value of a singularity for the vast, sprawling, complex cosmos we live in today.
So if this one law can potentially explain so much, from diamonds to the Big Bang, what's its ultimate potential? I mean, could this be the key we've all been looking for?
You know, the holy grail of modern physics is finding a theory of everything. One set of rules that unites the tiny quantum world with Einstein's massive universe of gravity and space-time. Well, Lie offers a conceptual bridge. By treating every single interaction, from a particle winking into existence to a galaxy merger, as a transaction on the same cosmic ledger, it gives us a potential path to finally connect them.
But look, this can't just be a fun philosophical idea. For this to be real science, it has to make predictions we can test. And Lie does. It would predict that particle collisions at the LHC must show perfect conservation of this value, not just energy. It would suggest that the power of quantum computers will always be limited by that entropy tax. We could even use the James Webb Space Telescope to look for value echoes in the oldest light in the universe. These are real, measurable things. This isn't just a story anymore. It's a hypothesis we could actually test, prove, or even break with experiments.
And that brings us right back to where we began. In the language of the story that inspired all of this, you could think of the gate of truth as the interface with that universal equivalence field. To learn something new, to create something incredible, to see the truth, you have to pay a toll. There's always a price.
Which leaves us with one final and maybe pretty profound question. If the universe really does run on this strict law of equivalent exchange, where every single gain is balanced by an equal and opposite loss, then what is the ultimate price we have to pay for understanding it all?